Use the given figure to find the area, x of the red larger square. These were used to solve this question. Label points A, B, C, J, D, E and F. Let angle CAB equals to theta, which equals angle DFE. Also, let the side lengths of the two unequal squares be y and q, respectively, as shown on the screen. From triangle CAB, y divided by 27 equals tan theta, and from triangle DFE, 64 divided by q equals to tan theta. Equate the two equations, so that y divided by 27 equals 64 divided by q. Cross multiply and we have that y times q equals 27 times 64. We call it equation G. Consider the red larger square of area, x. Its side length, by Pythagoras' theorem, is equals the square root of x. From the left-hand side of the given figure, the middle right triangle has an angle theta which is a corresponding angle to angle CAB. By trigonometric identity, the square root of x minus y are all divided by y equals tan theta. We call it equation 1. Also, from right-hand side of the given figure, the middle right triangle has an angle theta which is a corresponding angle to angle DFE. And by trigonometric identity, the square root of x minus q, all divided by q equals tan theta. We call this equation 2. This type of question required in-depth knowledge of trigonometric identities, similar triangle properties and Pythagoras' theorem. Equate equation 1 and equation 2. This implies that the square root of x minus y all divided by y equals the square root of x minus q all divided by q. Cross multiply and we have that the square root of x minus y multiplied by the square root of x minus q equals y times q. Expand brackets. Combine like terms and simplify. Rearrange terms in one side of the equation and equate to 0. We have that x minus the square root of x times the sum of q and y equals 0. Make x the subject of the formula. This implies that x equals the product of the square root of x and the sum of q and y. Rearrange terms. But square root of x divided by x equals 1 divided by the square root of x. It follows that 1 divided by the square root of x equals 1 divided by the sum of q and y. Cross multiply and we have that x equals the sum of q and y. We call it equation C. Label points T and K. From the left, similar triangles. Line AB divided by line B, C equals 27 divided by Y, which equals line AJ divided by line J or T. The result equals to the sum of 27 and Y all divided by the square root of x, as shown on the screen. Cross multiply and we have that the square root of x equals y multiplied by the sum of 27 and y all divided by 27. We call it equation R. Also, label point H. From the right, similar triangles. Line DE divided by line D, F equals 64 divided by Q, which equals to line EH divided by line HK. The result equals the sum of 64 and cube all divided by the square root of x. It implies that 64 divided by q equals the sum of 64 and cube all divided by the square root of x. Cross multiply and we have that the square root of x equals the product of q and the sum of 64 and cube all divided by 64. We call it equation P. Equate equation R and equation P. We have that y times the sum of 27 and y all divided by 27 equals q times the sum of 64 and q all divided by 64. Recall that from equation G, q equals the product of 27 and 64 divided by y. Substitute in the above equation. We obtained a new equation as shown on the screen, such that y times the sum of 27 and y equals 1728 times the sum of 27 and y all divided by the square of y. Equal terms in opposite sides of the equation cancel out. It implies that y divided by 27 equals 1728 divided by the square of y. Cross multiply and we have that the cube of y equals 27 times 1728. Find the cube root of the equation, so that y equals the cube root of 27 times 1728, which equals to 36. Back substitute y equals 36 into equation G to find the value of q. It imply that q equals 27 multiplied by 64, all divided by y, which equals to 48, after simplification of substituted value. From equation C, the square root of x equals the sum of q and y. Substitute values of y and q obtained into the above equation. This implies that the square root of x equals the sum of 36 and 48, which equals 84. Square the equation and we have that the square of the square root of x, which equals to x, is 7056 square units, as shown on the screen. Therefore, the required area of the red larger square, x equals 7056 square units.